This lesson is focusing on creating algebraic expressions to describe number patterns. So we are going to go through 3 tasks today. So task 1 is recognizing the pattern, task 2, using a formula, and task 3, creating a rule. So let's start off by recognizing the pattern in a few sequences. So here we have 12, 13, 14, 15. So we can see that the next numbers, we're just adding 1 each time. So each time we're plussing 1. So it's pretty simple to see that the next numbers will be 16, 17, and 18. For B, we have 180, 162, 144, 126, and we want to know what the next 3 terms are. So we can see that it's decreasing, so they're subtracting. So in your calculator, you can write 180 minus 162. And you'll see that they are decreasing by 18. So we can then do 126 minus 18, which is 112. 112 minus 18, which is, 108. 108. 108 minus 18 is 90. 90 minus 18 is 72. So let's have a look at this one. See, we have 7, 2, -3, -8. Again, you can see it's decreasing, so we are going to be subtracting a value. So what's 7 minus 2? You know that that's 5. So each term is subtracting 5. So -8 minus 5 is -13. -13 minus 5 is -18. -18 minus 5 is -23. So up until now, finishing the number sequences has been fairly straightforward. So let's look at other ways we can create and continue sequences and patterns. So now we're up to task 2, using a formula. A rule can be used to produce a set of output numbers from a set of input numbers. So let's have a look at this example. So example 1, we have a set of input numbers and then a set of output numbers. So we're putting in 3 and we're getting out 8. So what did we add to 3 to get to 8? We plussed 5. So let's see if this is the same for each input. So we're putting in 5 and we're getting out 10. So 5 plus 5 is 10. So we're putting in 89 and we're getting out 94. So again, we're plussing 5. So we can write this as a formula. So we want to know what the output is, which is represented by y. So to find y, we take our x value and we're going to add 5. So let's check this for our last one. So we want to know what y is. We want to know what our output is. So it's going to be our x value, which is 222, and we're going to add 5 to it, and we get 227. So this rule is correct. So let's complete the following tables using the given rules to work out the correct output numbers. So here we have our rule. Subtract 3 from each input number. So our first input number is 4. 4 minus 3 is 1. Our next input number is 10. 10 minus 3 is 7. 38 minus 3 is 35. 144 minus 3 is 141. So this is a rule, but it's in words. So let's write it as a formula. So we want to find out what our output is, which is y, and we know that we had to take 3 from our input number. So y is equal to x, our input, take away 3. So let's have a look at B. Here we have divide each input number by 2. This time we're going to write our rule first. So we want to find our output number, which is y, And we know that we need to divide our input number by 2. So now we are going to use our input numbers in our formula. Okay? So if we have y is equal to 4 divided by 2, we know that 4 divided by 2 is just 2. Now, we want to use y is equal to 10 divided by 2. And we get 5. Y is equal to 38 divided by 2. And we get 19. And lastly, y is equal to 144 divided by 2. And we get 72. So rather than finding the input or output for our tables, we could be given a visual pattern where we have to develop our rule. So let's move on to task 3, creating the rule. Okay, so looking at example 2, here we have a pattern with some counters. It is easy to see that you add 2 to each shape to get the next, to continue the pattern. So here we had 2 counters, then we had 4 counters, then we have 6 counters, and so on. But how could you easily find the 30th shape? Or the 152nd shape? How many counters in those? You could just keep adding 2 for 30 times or 152 times, but that would be tedious. This is where algebra can help. You can use algebra to describe a pattern of numbers. So first we need to formalize the pattern. So let's fill out our table to start with. So shape number, this is going to be shape number 1, shape number 2, shape number 3. So the number of counters in shape 1 is 2. The number of counters in shape 2 is 4. And the number of counters in shape 3 is 6. So can you see the relationship between the shape number, which is our top row, and the number of counters, our bottom row? So it's still tempting to say add on 2 each time, because you can see it's going 2, 4, 6. But the relationship is not x plus 2. So let's have a look at how the number of counters is found. You are adding on 2 each time, and multiplication is repeated addition. So let's have a look at this in more detail. So remember, we want to find the relationship between x and y. What did we do to x to get to y? Okay, so in this case, we know that there's 2 counters. So we would have multiplied our shape number by 2. So we had 1, our shape number was 1, and we multiplied it by 2 to get to the number of counters. Okay, so our next one, we look at our shape number 2 and the number of counters, which is 4. So we know for shape number 2, for each shape that we do, we're adding on 2 each time. But we can write this as repeated multiplication. So we can write this as 2 multiplied by 2. Let's look at our next one. So we know that we started with 2, then we added another 2, and then we added another 2. And here we get 2 multiplied by 3, because there's 3 lots of 2. So this rule can keep going for any number. So can you see the pattern? So our rule would be our number of counters, which is y, is equal to 2 times the shape number, which is x. So let's figure out this next question. So use the rule to work out how many counters needed to make the 30th shape. So let's write out our rule. Y is equal to 2x. But we're going to let x equals 30. Because we want to know the 30th shape, and we know that x is our shape number. So let's sub that in. Y is equal to 2 times 30. So y is equal to 60, but it's 60 counters. So let's do another one. So what shape number would use 142 counters? So let's state our formula. So y is equal to 2x. And what do we know? We know that we have 142 counters. So we know that y is the number of counters. So y is equal to 142. So let's sub that in. So we have 142 is equal to 2 times x. So we're going to have to do a little bit of algebra to find x. So we want to divide both sides by 2. So we get 142 divided by 2 is equal to x, because our 2's on this side would cancel out. And we're left with 71 is equal to x. So if you were to write this as a sentence, we have therefore shape 71 has 142 counters. So an extension question for you to do, we have another pattern here. So we have shape 1, shape 2, and shape 3. You need to complete the table, state the rule, and then how many counters are in shape 21. Thank you for watching.